Hello my friends and welcome back to the You Can Do TV channel. In the realm of tire manufacturing, Goodyear stands as a beacon of innovation and quality. One of the company's most commendable initiatives is its retreading process, a sustainable approach that breathes new life into used tires. This process not only exemplifies Goodyear's commitment to environmental responsibility but also offers a cost-effective solution for fleets, ensuring they get the most out of their tire investments. At the heart of Goodyear's retreading process is the initial inspection. This step is crucial, determining the viability of a tire for retreading. Using a combination of visual and electronic detection methods, experts meticulously assess each casing. The goal is to identify any damages or wear that might compromise the tire's structural integrity. If minor repairs are needed, the tire is marked accordingly and sent to the repair area. In the tire repair phase, damaged casings undergo various repair procedures tailored to the nature and extent of the damage. Simple nail holes or punctures, which are quite common, are addressed with precision. Depending on whether the tire will undergo heat curing, different repair methods, such as chemical cure cement or heat cure cement combined with rope rubber, are employed. More extensive damages, like those affecting the casing's wires or fabric, necessitate section repairs. The meticulous nature of this phase ensures that each tire is restored to a state where it can safely be retreaded. Buffing, the subsequent step, is where the tire truly begins its transformation. In this phase, the old tread is meticulously removed using specialized buffing machines. These machines are designed to not only strip away the worn-out tread but also to prepare the tire's surface for its new tread. During buffing, operators remain vigilant, looking out for hidden defects like sharp objects embedded in the casing. Any such defects are promptly addressed, ensuring the tire's surface is pristine and ready for the next stage. Building the tire is a pivotal step in the retreading process. Once the old tread is removed and the surface prepared, it's time to apply the new tread. Goodyear employs two primary building methods, pre-cure and unicircle. The pre-cure method is particularly popular due to the vast array of tread designs and sizes available. As the name suggests, in the pre-cure method, the tread is already cured before being applied to the tire. Depending on the tread's design, it might come in long strips that need to be cut to size or as seamless circles, like Goodyear's unicircle treads, which are stretched and fitted around the tire casing. Curing is arguably the most critical phase in the retreading process. It's here that the new tread is firmly bonded to the tire casing. This bonding is achieved through a carefully calibrated combination of time, temperature, and pressure. Goodyear employs a technique called enveloping to create a pressure differential between the inside of the casing and the outside of the tread, ensuring a strong bond. The enveloping process involves encasing the tire in a rubber membrane, which is then sealed off at the bead areas using specialized methods. Throughout the curing process, conditions inside the curing chamber are continuously monitored, ensuring optimal bonding of the tread to the casing. In the final inspection and finish phase, every tire is rigorously inspected for any potential issues, from separations and repair quality to overall appearance. Advanced tools, like the Matuzzi G100 high-pressure tester, are employed to detect even the minutest of defects. Once the inspection is complete, the tire undergoes a finishing process, where it's made to look as good as new, with vents trimmed, repairs buffed, and a fresh coat of black tire paint applied to its sidewalls. The Flat Track LT Re-Tire Force and Moment Measurement System is an advanced tool designed to simulate and measure tire behavior under various driving conditions, all within a controlled environment. Here's how it works. Simulation platform. The system employs a flat track, replicating the road surface, on which the tire rolls. This ensures that the tire experiences conditions similar to real-world driving. Application of forces. As the tire moves on the track, the system can apply different forces and torques to it, simulating scenarios like rapid acceleration, hard braking, and sharp cornering. This is crucial for understanding how a tire would respond to different driving maneuvers. Advanced sensors. Integrated into the system are sophisticated sensors that capture data on the tire's reactions. These sensors measure lateral and longitudinal forces, as well as the moments, torques, acting on the tire in real time. Dynamic control. One of the standout features of the Flat Track LT Re is its dynamic control capabilities. This allows researchers to make precise adjustments to the testing conditions, ensuring a wide range of scenarios can be explored. Data analysis. Once the data is captured, it's processed and analyzed to derive insights into the tire's performance characteristics. This information is invaluable for tire manufacturers, automotive engineers, and researchers aiming to optimize tire designs or improve vehicle safety.
Heavy rigs don't always need to be stationary. The Mr. 5000 is a fully mechanical mobile rig built for workover and conventional drilling. Designed to handle loads up to 250 metric tons, it combines carrier, mast, and drawworks into a compact, road-ready system. The mast lifts hydraulically and locks into position without cranes. On-site setup is fast thanks to its self-propelled drive and modular construction. Its compact design reduces site footprint and minimizes setup obstacles in tight spaces. The integrated drawworks eliminate the need for additional equipment, streamlining operations in the field. Steel snaps, hydraulics hiss, and everything locks into place with purpose. Each part is made for hard use, without wasted complexity. In remote or high-demand locations, this rig shows up ready. No fuss, no waiting. Steel rails don't go quietly. They're torn apart with brute force and precision. At Strasse in Zurich, crews dismantle tram tracks using a lineup of serious machines. The Hitachi ZX 670-3 handles heavy lifting, pulling embedded rails from concrete. Komatsu PC 210-10 and Liebherr A918 support with braking and sorting duties, working close to existing infrastructure. Compact excavators like the Takeuchi TB295W2 maneuver through tight urban space, chipping away asphalt and exposing aged track beds. Each segment is broken, lifted, and loaded with choreography only experience can teach, though we won't call it that. Dust rises, concrete cracks, and the rhythm of demolition sets the pace for what's next. Debris is carefully sorted for recycling, with safety fencing and traffic controls surrounding the site. In a city that never stops moving, even ripping out the old rails takes coordination, timing, and raw machine power. Building the MRT Putrajaya line pushes the limits of urban infrastructure. Elevated stations feature island platforms for better passenger flow and open sightlines to incoming trains. The construction integrates BIM and drone-based 3D survey models, improving accuracy across design and execution. Tunnel works run deep beneath active city life, requiring blind retrieval of decommissioned TBMs and real-time ground monitoring. Front box jacking was used to build a pedestrian tunnel beneath Kuala Lumpur's busiest highway, an impressive engineering feat. The autonomous TBM system, powered by AI, optimizes control of tunnel subsystems and outperforms manual operation while maintaining safety. These TBMs are monitored remotely at a central command center. Every milestone, whether viaduct completion, power system activation, or signaling test, feeds into a precise timeline. Smart use of LiDAR, cloud-based data sharing, and augmented reality tools enhances communication and quality assurance. Watching a mega project shaped by technology and grit, it's more than transport, it's progress made visible. A circular saw tears through solid steel up to 2,160 millimeters. Emulsion flows fast. Precision isn't optional, it's enforced.
The Coro Mill MS60 is a versatile milling solution designed primarily for 90 degrees shoulder milling, but it also excels in a variety of applications like face milling, ramping, pocketing, and dynamic milling. Its design delivers efficiency, cost-effectiveness, and superior performance for roughing and semi-finishing operations. Key features and functionality: 6-edged inserts. The double-sided inserts provide 6 cutting edges, optimizing cost efficiency while ensuring excellent cutting performance. They are capable of ramping operations with a cutting depth of up to 8 mm, 0.315 inches. The inserts also feature a wiper edge, ensuring superior surface finishes. true 90 degrees shoulder milling. The tool maintains precise 90 degrees angles, making it ideal for producing accurate shoulders and sharp corners without additional operations. Ramping and pocketing. With advanced ramping capabilities, the Coromill MS60 can handle entry cuts and complex pocketing operations seamlessly, enhancing machining flexibility. Application versatility. It is suitable for materials like steel, ISO-P, cast iron, ISO-K, and even challenging materials such as stainless steel, ISO-M, and heat-resistant superalloys, ISO-S. This makes it ideal for components like housings, machine beds, pump parts, and valve casings. Cutter body design. Available in diameters from 50 to 100 millimeters, metric, or 2 to 4 inches, inch. The cutter body is equipped with internal coolant for improved chip evacuation and thermal stability. It also features differential pitches, coarse or close, to minimize vibration during machining. Durability and cost efficiency. The 6-edge design significantly reduces the cost per edge, while the robust cutter body ensures reliability across demanding applications. Applications. The Coromill MS60 is ideal for general engineering tasks, particularly in industries producing machine tables, headstocks, and pump, valve parts. It combines high performance with adaptability, offering a dependable solution for both roughing and semi-finishing operations.
This CAT 3516 engine rebuild starts with total disassembly. 1.6-ton cylinder heads lifted, pistons pulled, blocks stripped bare. Each part is cleaned, inspected, and restored to spec. Watching this monster get rebuilt piece by piece, it's gritty, methodical, and honestly, kind of satisfying to witness. XXL monopile production begins with feeding plates up to 4,200 millimeters wide and 180 millimeters thick into a 4-roll bending system. Linear guides stabilize motion while pre-bending hits 160 millimeters thickness. Each pass shapes massive curves with millimeter accuracy. Watching steel bend like that, it's raw power under complete control, forged for wind giants rising offshore. This CAT 7495 shovel overhaul is all about scale and precision. The upper frame, weighing over 90 tons, is lifted with synchronized cranes. Major components, motors, gears, and the crowd mechanism are removed, rebuilt, and realigned. Each bolt matters when the machine weighs nearly 1,400 tons. Seeing giants like this taken apart and brought back, there's something thrilling about restoring that much steel to full power. The thud of each drop forge echoes with force. This is where metal meets its shape. At Ganga Forging, massive dies shape parts under pressures of 400 to 450 metric tons. Milling machines, VMCs, and drills refine the surface. Pit marks and scaling are checked thoroughly. Each forged part holds the weight of industrial power. At Rank-Zanini, gear reducers for cement mills, sugarcane grinders, and submarines are forged, hardened, and ground with tight DIN 3962 specs. Massive parts, up to 3 meters, undergo heat treatment processes like oil quenching and gas case hardening. Precision here isn't optional, it's built in. Concrete, steel, and seawater. The elements clash as austere marina rises along the Vouliagmeni coastline. The construction begins with underwater excavation and sheet piling, forming a solid barrier against the Aegean. Next, cranes maneuver massive precast caissons, each weighing hundreds of tons, into exact positions. These units anchor the breakwater and support the future marina. Above water, reinforced concrete decks take shape over steel piles, built section by section. Crews pour concrete in phases, ensuring structural integrity under tidal shifts. Utility ducts, drainage systems, and lighting networks are embedded as the slabs are cast. Function built into every layer. Floating docks are assembled off-site and towed in for final alignment. They're secured using pile guides to allow vertical movement with the tide. Finishing touches include pedestrian walkways, mooring bollards, and landscaped public areas. This project isn't just construction, it's engineering against the sea. Watching each layer fall into place is oddly calming, like seeing a harbor grow muscle and bone before your eyes. Roads rise across Mombasa as machines reshape Kenya's coastal corridor. Crews expand highways to 6-lane dual carriageways with elevated interchanges and service roads. The Mombasa-Mariakani section now handles over 19,000 vehicles daily. New links to ports, airports, and the northern corridor streamline cargo flow. Watching bridges form and lanes stretch out, there's a strange beauty in asphalt, steel, and sweat pushing a nation forward. Molten metal pours, presses stamp with precision, and laser welders spark to life. At the end, assembled pumps ready to push water with power. Watch how heat exchanger coils are built, tested, and fine-tuned. Tubes are expanded tightly against fins for maximum heat transfer. Engineers test performance in a custom wind tunnel using live refrigerants. Heat must move efficiently. There's no room for guesswork when systems depend on it. Metal components for industrial machines begin here. Steel sheets are deep draw stamped into precise forms. Some compact, others complex. After forming, each piece is washed and phosphate coated for durability. Machining, welding, deburring, and assembly follow in tightly managed steps. Every operation is done with safety and clean processes in mind. Nothing fancy, just solid parts built to perform. This is how aluminum extrusion takes shape under pressure, heat, and control. Aluminum logs are sliced, heated to 900 degrees Fahrenheit, and forced through a steel die by a hydraulic press. Each profile is quenched, stretched, and aged in ovens to meet exact specs. Infrared cameras monitor billet exit and quench temperatures with tight tolerances. CNC saws trim parts to custom lengths, while vibratory finishers smooth the surface. It's pressure, timing, and heat, refined into repeatable accuracy every time.
The large crankshaft manufacturing industry plays a crucial role in supporting heavy-duty applications across sectors like marine, power generation, and heavy machinery. These components are pivotal in converting linear motion to rotational motion in engines, enduring high stresses while ensuring performance and reliability. Industry size and scope. The global crankshaft market, valued at approximately $3.1 billion in 2023, is expected to grow at a CAGR of 4.2% through 2030. A significant portion of this value comes from large crankshafts used in marine and industrial applications, which can weigh up to 15 tons and reach lengths of 12 meters or more. These crankshafts are manufactured using advanced forging or casting techniques, ensuring high strength and fatigue resistance. Production process. Material selection. Typically, large crankshafts are made from high-grade steels or alloys like 42 CRMO4 or Ni CRMOV due to their excellent mechanical properties. A large crankshaft may require 10 to 15 tons of raw material. Forging and machining. Forging processes involve the use of massive hammers or presses with forces exceeding 12,000 tons. Precision machining follows, removing up to 30% of the raw material to achieve the final geometry. Heat treatment. Crankshafts undergo induction hardening or nitriding to enhance wear resistance. This can involve surface temperatures of over 900 degrees Celsius and cooling rates of 100 degrees Celsius per second. Quality control. High precision is maintained with tolerances often within 0.02 millimeters. Each crankshaft undergoes rigorous non-destructive testing, NDT, like ultrasonic inspection to detect internal flaws. Key markets and applications. Marine engines. Large crankshafts dominate this sector, powering vessels with outputs exceeding 50,000 kilowatts. The marine segment constitutes about 35% of the total crankshaft market. Power generation. Crankshafts are integral to engines in power plants, handling 500 to 1,000 revolutions per minute and high torque levels. Industrial equipment. Heavy-duty applications in mining and construction also drive demand. Challenges and trends. The industry faces challenges such as the high cost of materials, long lead times, often 6 to 12 months for bespoke crankshafts, and energy-intensive production. However, technological advancements like additive manufacturing for prototypes, CNC machining, and sustainable material sourcing are reshaping the sector. The large crankshaft manufacturing industry stands as a backbone for critical global infrastructure, with its growth tied to innovations and increasing demand for heavy-duty machinery. The management of waste tires is a growing environmental concern, and small machines designed for this purpose are making a significant impact. These machines are not only compact but also efficient, making them ideal for both small and large-scale operations. The first step in the tire processing journey involves cutting the entire tire into two parts. This is achieved using a specialized machine with a capacity to handle 60 to 80 tires per hour. Operating on a power of 5.5 kilowatts, this machine ensures that the tires are halved efficiently, preparing them for the next phase of processing. Following the initial cut, the halved tires are then processed to be transformed into rubber blocks. These blocks, measuring between 50 to 80 millimeters, are produced automatically by a machine with an impressive capacity ranging from 3,000 kilograms per hour to 6,000 kilograms per hour. Requiring 25 kilowatts of power, this machine is designed to handle the whole tire, ensuring a high-capacity output with safe operations. Lastly, the new type tire shredder is a game-changer in the waste tire processing industry. This machine can take in the entire tire as input, even those with a maximum diameter of 1,400 millimeters. Its high-speed operation allows it to crush a tire in just 10 seconds. With a processing capacity of 5 to 8 tons per hour, it produces rubber blocks sized between 250 to 400 millimeters. Remarkably, this high efficiency is achieved with a power consumption of only 18.5 kilowatts. Tire baling plays a pivotal role in the tire recycling sector. It involves the compression of discarded tires into dense, easily transportable bales, which are then forwarded for recycling. The hydraulic tire baler, specifically the R42 tire baler, stands out as a cutting-edge machine tailored for this purpose. Its prowess and durability are showcased in its capacity to bale a substantial number of tires into a singular compact unit. In this video, the R42 tire baler compressed 91 mixed tires, producing a single bale weighing approximately 834 kilograms. This bale, with dimensions of roughly 183 centimeters by 102 centimeters by 112 centimeters, is primed for the subsequent phase of tire recycling. In another instance, the baler commendably compacted over 110 mixed-size tires, resulting in a bale that weighed in excess of 1,020 kilograms, maintaining the same dimensions, ready for both transport and recycling.
Physically open the door all the way, which is going to get strong stuff. Slowly feed the wire through to the other side.
The design and technical specifications of the R42 tire baler are fine-tuned for peak performance. With overall dimensions of 229 centimeters in width, 135 centimeters in depth, and a towering height of 386 centimeters, it's evident of its substantial capacity. The baler chamber, where the tires undergo compression, has a depth of 107 centimeters and a height of 112 centimeters. The feed height stands at a convenient 66 centimeters, facilitating easier tire loading for workers.
Two second ones in, which are in line with the ejector chains, which they're going to use to eject the bale. That's good. That's good. With the bale tied off with all 6 straps,
the baler's cylinder bore measures 18 centimeters by 10 centimeters, and it boasts a rod stroke of 122 centimeters, ensuring efficient tire compression. Driven by a 20 horsepower motor, the baler operates on a 3-phase electrical system, with voltage options of 208, 230, or 460. The control voltage ranges between 110, 120 VAC. The spacious load opening, measuring 183 centimeters in width and 66 centimeters in height, can accommodate a significant number of tires. Once compressed, the bales measure 183 centimeters in width, 107 centimeters in depth, and 122 centimeters in height. The Eagle International Titan OTR tire shear is a state-of-the-art solution for enhancing the flexibility of your off-the-road OTR tire cutting system. Designed to handle large tires, the Titan can effortlessly cut tires up to the size of 27.00 R49. The machine is equipped with 3 hydraulically powered rollers that facilitate the positioning of the tire. These rollers not only move the tire from side to side and front to back, but also enable it to rotate in a circular motion. To ensure precision and safety during the cutting process, a hydraulic probe arm is incorporated to help position and securely hold the tire. The operator has full control over the cut size, ensuring adaptability to various requirements. Additional features of the Titan include an operator control stand and the choice between electric or diesel power options. The Eco Razor 63 operates as a state-of-the-art solution for rubber removal, specifically designed for processing some of the largest tires in existence. Its functionality is rooted in a patent-pending technology. Here's how it works. Rubber removal. The machine is engineered to extract valuable rubber from all 3 sides of a tire. This comprehensive extraction ensures maximum rubber retrieval, leaving minimal waste. Blade configuration. One of the standout features of the Eco Razor 63 is its adjustable blade configuration. By making minor adjustments, operators can alter the size of the output material. This flexibility allows processors to produce rubber sizes that are most in demand in the market, optimizing profitability. Screening and packaging. After the rubber extraction process, the retrieved rubber is prepared for the next stages. It undergoes screening to ensure quality and consistency. Once screened, it's packaged and made ready for sale. Downstream processing. Post the rubber extraction, the remaining tire isn't discarded. Instead, it's channeled downstream for additional processing. Alternatively, it can be repurposed into various useful products, showcasing the machine's commitment to sustainability and resource optimization. The Eco Extractor 63 is a groundbreaking machine specifically designed to extract steel beads from the world's largest mining tires, particularly those with a 63-inch (1.6 meters) rim. This innovative equipment stands out due to its proprietary design, which ensures the efficient extraction of clean beads from these robust tires, which are otherwise nearly indestructible. One of the standout features of the Eco Extractor 63 is its unique reverse hook design. This, combined with an automatic bead ejector, streamlines the extraction process, making it swift and efficient. The machine's design prioritizes safety and efficiency, allowing for a single operator to control the entire process remotely. This single-person remote control operation not only reduces labor costs but also enhances the speed of the bead extraction process. In terms of specifications, the Eco Extractor 63 is built to handle tires up to 63 inches (1.6 meters) in rim size. Once processed, the output material consists of large steel beads separated cleanly from the tire. The machine boasts an impressive capacity, able to process up to 10 tires per hour. It is powered by a 125 HP engine and has dimensions of 6.7 by 2.4 x 2.4 meters with an extractor width of 18 meters. The introduction of the Eco Extractor 63 is a significant leap in the tire recycling industry. Brad Swenson, the president of Eco Green Equipment, expressed his enthusiasm about the machine, emphasizing its potential to revolutionize the recycling of large mining tires. The primary advantage of the Eco Extractor 63 is its ability to make tire recycling more straightforward, efficient, and profitable. By processing more tires in a shorter time frame, businesses can increase their profit margins while also contributing positively to the environment. Rubber recycling plays a pivotal role in environmental conservation and sustainable resource management. As the global demand for rubber products, especially tires, continues to soar, the amount of rubber waste generated has become a significant concern. Discarded tires, if left untreated, can become breeding grounds for pests, contribute to environmental pollution, and pose fire hazards. Recycling rubber not only addresses these environmental issues but also offers economic benefits. By repurposing used rubber, industries can reduce the need for virgin rubber, leading to decreased deforestation and habitat destruction. Recycled rubber can be transformed into various products, including playground surfaces, asphalt, and even new tires. This process not only conserves resources but also reduces the carbon footprint associated with rubber production. A prime example of the rubber recycling industry's innovation is this rubber recycling line with waste-less tire recycling. This state-of-the-art facility can process up to 3 tons of tires per hour. The efficiency of such a line means that in a single day, vast amounts of discarded tires can be transformed into valuable materials, ready for reuse in various applications. By adopting such advanced recycling methods, we can ensure a more sustainable future, where resources are utilized to their maximum potential, and environmental harm is minimized. Here is a detailed overview of the manufacturing process of rubber mats rolls for gym flooring. Sifting crumb to remove impurities. The crumb material is sifted to remove any impurities, ensuring the quality and purity of the rubber material. Mixing colorful crumb with poo binder. In this step, 1 kilogram of poo binder is mixed with 8 kilograms of colorful crumb material. This mixture is essential for binding the rubber crumb together. Uniform mixing. The crumb and poo binder mixture is thoroughly mixed for approximately 8 minutes to achieve a uniform blend. Uniform mixing is crucial for product consistency. Filling molds. The mixed crumb is then filled into molds, and it takes approximately 15 minutes to completely fill a mold. Hydraulic pressing. The filled molds are subjected to a hydraulic press with a pressure of 31.5 MPa. This pressure helps compact the material and give it the desired density and thickness. Mold fixation. The molds are fixed in place to maintain their shape during the vulcanizing process. Vulcanizing. The molds are kept in place for 24 hours for vulcanization. This process enhances the durability and elasticity of the rubber material. Removing rubber columns from molds. After vulcanization, the rubber columns are carefully removed from the molds. Fixing rubber columns on whirling machine. The rubber columns are fixed onto a whirling machine, which is used for cutting the material into rolls. Cutting with precision. Cutting is controlled by computers to ensure precision. The distance between cuts can be adjusted to achieve different thicknesses as required. These rubber mats are available in various thicknesses, ranging from 4 mm to 12 mm, widths 1 m, 1.2 meters, 1.25 meters, and lengths, customizable between 10 meters to 20 meters. The final products are not only durable and slip-resistant but also eco-friendly, non-toxic, tasteless, and fireproof. Final cutting and measuring. Each roll is cut to a specific length, and extra care is taken to cut off approximately 1 meter at the beginning and ending of each roll. This ensures that every roll is uniform and meets the specified length requirements. This comprehensive manufacturing process at Acapella Rubber Industries guarantees the production of top-quality rubber mats rolls that meet a wide range of customer needs while maintaining a strong focus on eco-friendliness and safety. Rolling, printing, and packing. The final step involves rolling the rubber mats, printing labels or branding as needed, and then carefully packing the rolls for shipping to customers. Seamless crumb rubber coatings are a popular choice for various surfaces due to their advantages, including their aesthetic appeal, durability, and low maintenance requirements. Primer creation. Necessary components are mixed in precise proportions to create a primer. This primer serves as a bonding agent and is applied to the prepared substrate. It ensures a strong adhesion between the surface and the rubber coating. Mixing raw materials. In parallel with the primer preparation, the raw materials for the rubber coating are mixed. This mixture typically includes crumb rubber, pigment dye for coloration, and adhesive glue. The proportions are carefully measured to achieve the desired consistency and properties. Combining components. The crumb rubber is added to the mixing process, followed by the pigment dye. The adhesive glue is introduced at the last moment to ensure a uniform mixture. Smoothing. After the application of the rubber coating, the surface is smoothed using rollers. This step helps in achieving a uniform and seamless finish. Drying and curing. Once the coating is applied, it needs time to dry and cure. Typically, it takes about 24 hours for the glue to set completely. After this period, the surface is ready for use. One of the advantages of seamless crumb rubber coatings is their flexibility in design. Patterns and color transitions can be incorporated as per the client's preferences. To do this, a section of the coating can be cut out, cleaned, and replaced with a mixture of a different color. This new mixture is rolled out using a roller to create intricate patterns.
Two 50-ton cranes lift a 20-foot, 45,000 pounds rotor with just 3/4 radial clearance. One wrong move, and it's metal meeting metal. This is control at a colossal scale. Red-hot blanks hit 900 degrees Celsius before forming under massive pressure. The die cools parts instantly, locking in strength. Watching steel harden in seconds. It's aggressive, precise, and makes lighter but stronger feel completely real. Inside this facility, fire and metal shape the future of power. It all starts in the wax room. Wax pellets are turned into patterns, dipped in ceramic and fired to form hollow molds. Super alloy metal is cast into turbine blades, then refined through grinding, machining, and X-ray inspection. It's precision forged by heat. This 300 mm wide beam stretches 21 meters long. Inner stiffeners are positioned and tack welded before full seams are laid across 8 mm thick plates. That glowing weld, deliberate and unforgiving, is where raw material meets craftsmanship in structural steelwork that demands both precision and strength. It begins with steel slabs heated beyond 1,200 degrees Celsius, rolled and quenched by high-pressure water jets. The cooled strips are then fed into forming lines, shaped into W-beam guardrails by a series of rollers. Mounting holes are punched and sections are cut to length. Hot dip galvanizing adds corrosion resistance. Final checks verify strength and dimensions. That moment when red-hot metal cools into form, its raw force turns safe and precise. These aren't just beams. They're impact-ready barriers built meter by meter. Crane beams are assembled with force and precision. The process begins with aligning web and flange plates on the beam assembly machine. Hydraulic clamps hold everything tight while operators tack weld the joints. Once secured, the heavy beam, sometimes over 20 meters long, is flipped using an overturning machine built to handle massive loads. This rotation exposes the underside for full seam welding. The welding unit then travels along the length of the beam, fusing the components with a consistent arc, often working on thick sections up to 20 millimeters. Temperature control and travel speed are monitored in real time to prevent warping. As the weld cools, you can almost feel the strength locking in. The scale of it, the rhythm of machines, the glow of molten metal, it all adds up to something more than structure. These beams will carry tons of moving weight. Yet every millimeter is calculated. This isn't casual fabrication. It's the backbone of cranes, built for heavy-duty performance without compromise. Crafting a wooden barrel is poetry in wood and steam. In this workshop by Frederick Gillet, you'll see staves, long, narrow wood pieces, heated and bent over a fire to form the curve of a barrel body. Each stave is then positioned upright in a temporary metal frame, and the cooper uses metal hoops to clamp them tightly. With rhythmic hammering, the hoops are driven down, compressing the staves into a snug cylinder. Moisture and fire work together here. The wood is softened, not burned, allowing clean curvature without splitting. No glue, no screws, just wood, heat, and pressure holding everything together. Next, the head is fitted, precisely cut circles of oak. Placed inside grooves at each end. Before that, grooves are carved into the barrel ends using a draw knife and compass tool to ensure a tight seal. The cooper cuts the joints flush and rotates the barrel on a lathe-like cradle to trim excess. A final sanding gives it a clean surface, preparing it for branding and aging. It's fascinating to watch craftsmanship honed over centuries. Glowing embers, oak aroma, wood yielding to steam. The process is tactile and deliberate. Seeing wood transform into a barrel ready for wine or spirit aging gives serious respect to traditional skill. Each step demands judgment. The cooper feels the flex of each stave, listens to the ring of each hammer strike. This mobile atelier brings that heritage alive, traveling through Burgundy and beyond to share the art. Whether for winery events, family open days, or cultural festivals, this demonstration turns coopering into a living experience, a blend of fire, water, and wooden artistry. Watch closely. This isn't your average boat hull. UV-stabilized HDPE sheets are cut, welded, and molded into rugged forms at Turbine. These recyclable hulls resist corrosion, flex under stress, and shrug off impacts like it's nothing. Built for abuse.
The Fabrication CNC mill employs rotary cutters to machine brass by precisely removing material from a workpiece. Using multi-axis capabilities, the machine executes complex operations, such as drilling, contouring, and 3D shaping, by moving the workpiece and spindle simultaneously. The machine's CAT30 spindle allows rapid material engagement, while high-speed tool changes, 1 second, ensure efficiency during production. Linear guide construction improves precision and durability, crucial for intricate brass components. With features like a remote manual pulse generator and fourth-axis capabilities, the machine offers flexibility for producing curved surfaces or cylindrical parts. Additional options, like rotary tables and wireless probing, streamline setup and ensure consistent accuracy. Benefits of CNC milling machines. Precision. CNC mills achieve exceptional accuracy, producing complex shapes with tolerances as tight as plus or minus 0.001. This is critical when machining brass components with intricate designs. Efficiency. High-speed operations and rapid tool changes, 1 second tool to tool, maximize productivity. Multi-axis capability reduces the need for repositioning, shortening cycle times. Versatility. CNC mills handle diverse applications, from flat surfaces to 3D profiles. They are ideal for industries like automotive, aerospace, and electronics. Automation. Advanced controllers and features like wireless probes automate processes, reducing human error and increasing repeatability. Compact design. Machines with a small footprint, like the Fabrication CNC mill, 5 feet by 12 feet, fit small shops while maintaining high output, making them space efficient. Durability. Linear guide construction ensures rigidity and minimal wear, maintaining consistent quality over extended use. Customization. Optional features, such as rotary tables and 15K24K RPM spindles, expand functionality to meet specific requirements.
Clean, fast, and precise. This is how PU foam should be cut. The CNC milling machine, paired with DATRON's specially designed foam tools, makes sculpting polyurethane feel effortless. As the spindle spins at high speed, the tool slices through foam without melting, tearing, or leaving frayed edges. Bevels, sharp contours, and deep surface textures are achieved in just one pass. It's fascinating to see such detailed geometry formed so cleanly. This process is widely used to manufacture insulation inserts, protective packaging, and mock-up components. Compared to water jet or laser methods, this dry milling technique avoids post-processing and material damage. The multi-axis system ensures fluid toolpath transitions, minimizing manual adjustments while maintaining a whisper-quiet operation. Datran foam mills, with their custom shank geometry and efficient chip evacuation, create smooth results with tight tolerances. Watching the foam part emerge, ready for use, is oddly satisfying. For engineers or designers working with PU foam, this solution redefines productivity and control in prototyping and manufacturing.